So in case you didn't get anything during that last conversation, François is going to talk to us about fonts. So it's all yours.
Thank you. I welcome you, and I'm pretty surprised that I'm facing that many people. I thought that there will be perhaps 3 or 4 persons, so a little bit more personal, okay. But I try to do my very best. So, who am I, if I may introduce myself? My name is François Fernandes. I'm a developer at Bermuda Solutions GmbH. That sounds a little bit weird in English. And I am responsible for the PDF support in our product. That, to demystify this, I'm the guy that has to implement everything that our customer claims that is a bug. And I am a co-chairman of the PDFA technical working group, a little group inside the PDFA association, or the PDF association within the PDFA competence center. And we care about, well, everything that is technical around the PDFA standard. So, my history, a little bit of history. When came PDFA out? What is it published? 2005.
2005.
Exactly. Okay, I've started to work for Levigo 1 year before, and I came into my company, and they tossed the PDF reference on my desk. I had no knowledge about Java. I had to implement a reader in Java from the first day I've been there, and now I'm here. So
you should be more honest when you do your interviews.
Sorry?
You should be more honest when you do your job interview. Say, I can't everything, you know?
I simply told I can everything. I know everything. So. Okay, so what do I want to tell you today? To have a little bit of an agenda. I guess some of you have seen exactly this. The little nice rectangles around there, the missing characters, and of course, simply garbage.
Especially another version of this. This all looking correct, but copy and pasting then looking like that.
So I have a cure, the Mighty Mouse, for the rescue, to have a correct agenda. Okay, we start with the basic question: text. What is this? And I often heard that it isn't not that difficult. Even I myself, when I started to implement it, I thought it can't be that difficult. It's the first part that I will get done when I'm implementing it on PDF parser. I've been wrong. Perhaps others have made the same experience. After this, let's have a look at the font file formats that PDF supports. And of course, how to acquire the glyphs within those font file formats. And finally, one interesting part that is also very important and very misunderstood too, is how I can extract text out of a PDF document, not PDFA, general PDF document. Okay, text that cannot be that difficult. Let's look at something that is easy. In my opinion, that is easy. Writing with ink on paper. That is completely easy. Complicated it gets if you have any kind of digital publication, or digital letter, or anything. Everything is digital is complicated. All my colleagues disagreed. I hope I can prove that I'm right with my opinion. If we have text and we have something that we want to display, there are two things that are involved. One, expectation, and the source of what we expected. We have on the one side, we have binary data in any format, and we want a visual representation of that. Already here, the problem begins. What is the binary data? Binary data could be a lot of different things. in my example, to keep things simple, I've used the ASCII representation UTF-8 and UTF-16, which is a bit malformatted here on the screen. This is sad.
That's actually UCS2, that's not UTF-16.
It should be UTF-16. It has
No, FFFE, the BOM makes it UCS2.
because of the ordering.
The byte ordering mark means it's UCS2.
Okay.
Because everything is 2 bytes.
Okay. It's not
But I
that
agree with
great
you, it's another
because
code.
UCS2, which we'll see later, has a 96% match to UTF-16 for that reason. I think it's okay. So we have different kinds of input data, and we want the same, exactly the same result in this case. Everything works in the other way around. We have one source of data and want different outcomes. In here, different types of letters that are seen on the screen. Now, the problem gets even worse if we combine the both worlds. What we have to do now is to find the correct path from the source data to our target. And PDF itself talks not really, only in a few sentences, about the source. It doesn't really talk about the target. It is all about the connection of the source data to the target. How to get the data in the form that we expected. It's explained a little bit because we have the binary data in any form inside the PDF document. So let's come back to my opinion that the writing with ink is simple and digital documents are complicated by looking at the technologies that are involved. On the one side, it's very easy. We have ink and paper. There's not much that can go wrong. On the other side, we have a lot of stuff. We have the document format, we have the encoding, we have the font file formats, we have the different character bytes associated with an encoding. We have the glyphs and we have the glyph matters. And there's a lot of additional information inside the documents. So I hope you agree with me that the right side is sometimes a little bit more complex. But it would be sad if we have not complex tasks. So what is the process to get from binary data to a visual representation? The process is relatively straight. We have to read the context, we have to decode the text content. That looks pretty different on Mac than on Windows. We have to map to the glyphs, we must lay out the glyphs, and finally we render the glyphs on screen, on paper, on any device that we need. Now, there's two main parties that are involved in the whole process. That is, on the one side, the document format that defines how a lot of things have to be done, and the font file format, which itself defines a lot of things how they should be done. And they overlap in a lot of situations. So, the process on how to get a visual representation is simply by combining the knowledge of our source data, our target, of course the outlines, the images which are represented as the glyphs are represented as images in outlines, the layout data, the hinting data, and there's a lot of more data to get the resulting representation that we wanted to have. Okay, so far for a little bit for the basics. Let's have a look at what we have in addition. One thing, this session is meant to be interactive. I don't want to feel too alone here in front. So if you have any question, if you have an opinion that you might want to cry out, I'm pretty happy with it, so go ahead. Even the attendees from external, they can ask questions via the chat. I think you're surveying it. Okay. Good. Font file formats. What is a font file format? First of all, we have to check what is a font. What do we expect from a font? What is the definition of a font? Basically, It's a collection of glyphs. With the glyphs, it contains the appropriate layout data. That means the width of the glyphs, the line height to some degree, the kerning information, the ascender, the descender, the font box, and a lot of additional information. And it contains lookup information to find the glyphs. This is different from each format to another. And usually, this is what we expect. It is a visual representation of textual data, something that we can read. Sometimes it is not. We have here a nice example. So what are font file formats? Font file formats are nothing else than a technical description of a specific font. It is basically a container for font data, and it defines how glyph outlines are stored, or glyph bitmaps, depending on what technology you use, where and how the glyph metrics are stored. Of course, the mapping tables, naming tables, and everything that is associated with a font. And it specifies how to process the character codes and, of course, the glyphs, because you have to know what to do with the glyph data, of course. So, to have a quick overview of what font file formats exist for the use inside PDF. At the beginning, there was type 1. Oh no, it's
You didn't use PDF, did you?
PDF doesn't have animations. That's sad.
Yes, it does. It most certainly does.
It does if you have page.
Nope,
transitions.
interpage transitions, press steps, introduced in PDF 1.5 as part of optional content.
Oh my god.
But there's no authoring tools.
One. The PDF maker for PowerPoint from Adobe.
But it's on Windows.
What? Okay, but
He runs Windows.
I'm running Windows, but I didn't find the option to integrate the animations.
There you go.
Okay, so we have a little problem here. It looks quite better if you're using the PDF version on any operating system. I hope so. We get ahead anyway. From the it's so ugly. I'm sorry. I can't tell anything because it's so ugly.
It's a fun problem.
Okay, we have it's a fun. It's very exciting. Portability, no. Okay, we have the CFF, which is the little brother of Type 1, which is simply a compact representation. Apple, on the other hand, has oh my god!
Wow. We love you, PowerPoint.
I love the PowerPoint. Yes, great. Or I fear there are some other effects that will not be beautiful. Egal. Apple has specified TrueType because of a little conflict between Adobe and Apple from some time ago, as far as I know. And later on, Microsoft licensed the TrueType technology for Windows 3.11. Yes, it's that old. And later on, implemented the OpenType, which is nothing else than an extension of TrueType with additional functionality. And
So OpenType was actually co-developed with Adobe.
yes, exactly. But line shows.
Oh, there it is.
Give me a
Missed that
second.
one. Sorry, you know what? We get upset about this. There it is.
It was started by Microsoft alone, as I am aware of, and later Adobe came within to help with the standardization, as to my knowledge.
No, because the original development was code because Microsoft brought in the TrueType outlines and we brought in the CFF-based outlines.
Okay, it was very at the same moment that Microsoft and Adobe started.
Microsoft had the idea first and brought it to us.
Okay, so the line was correct.
The line was correct.
But without Apple.
Yes, definitely without Apple.
No Apple ever in that situation. And we have in PDF a very, very special font file format, but it's not a really font file format. It's something embedded in the document, and that's type 3. Oh, it's ugly too. I'm sad, man. No. Okay, it's it's a very special thing. So, but I wanted to mention it on the slide. So, to have a quick overview of what these font file formats are and how they are defined, we have Type 1. Type 1 has a PostScript history and itself is defined using PostScript operators with some additions. And some additions. It has an encoding, oh my god, it's ugly too, that is built in. That means you have means to use character codes, map it directly using a encoding specified within the Type 1 font, and map it to glyph names. And this is also the way how Type 1 glyphs are accessed. They are accessed by an explicit name. TrueType, so PostScript is something, of course, I think everyone knows, is ASCII based. TrueType, on the other hand, is something binary. It is even a format that, in its origin, it was possible to map it to C structures and put it directly in the memory and let any structures point into it. It has an encoding that is built in. It is a bit more flexible regarding the encodings, because you can integrate a lot of different encodings into one single TrueType font. And you're accessing the glyphs via the glyph ID. OpenType, just to have it all together, is binary. Okay, it's based on TrueType basically. It has a built-in encoding, which is almost the same as TrueType, but the glyph access depends on the variant that you're using, because you can have an OpenType font with bitmaps in it. You can have an OpenType with CFF in it. You can have an OpenType font with TrueType outlines. Okay.
So it's not necessarily based on TrueType.
It's the structure of an OpenType is completely the same as a TrueType font, but a TrueType font is based on tables. It has a lot of tables in it, and the table directory and the general structure of the font is derived by TrueType. There's one exception, that is some tables are required within a TrueType font, but are not required in an OpenType font, just to allow it to embed only bitmap glyphs or CFF glyphs without the need to embed any kind of TrueType glyph or data like this. Okay. Now, CFF, as I told before, is basically a very compact representation of Type 1. There are some calculations of how numbers are interpreted and encoded, decoded, that can bend your brain a little bit. It too has an encoding that is built in. It's almost identical to that what Type 1 does. And glyph access is, in most cases, by name. You can also access the glyphs directly via its index. It's useful in some situations, but we will see that later. Type 3, as the last kind of font file, is a virtual file. It is based on PDF structures. That means every glyph within a Type 3 font is almost similar to an X object that you can place anywhere on the document, but in here used as a font. And glyph access is done by names.
What about CID fonts?
I'll get back to them. The CID fonts have no own font file. Here's only about the font files in the CID fonts itself. Within PDF are a structure inside PDF, but we'll see that later. Okay, so much about the subject of the font files. The most important part, visual important part, is how to obtain the glyph. And this is also the most complex part. We have here two different types of PDF fonts, not font file formats. the structure within a PDF can contain two kinds of fonts, simple and composite. The simple are limited to 256 characters, not a single more, because you have one byte and this byte must be mapped exactly to one glyph. The mapping is relatively simple, not in every case, but in most. And we have possible font file formats that can be used as a target for the fonts. We have true type, we have type 1, we have open type, CFF, and type 3. Now, composite fonts are a little bit more complex. They allow to support larger character sets. That means CJK fonts, for example, CJK documents, if you have the need. And even it does make sense to use type 0 type 0 fonts within countries within Europe. The mapping is a little bit more complex because there's a little bit more technology involved. And there's a limit of which font file formats can be used. It's true type, open type, and of course CFF. So what's the basic concept of how that works? We have on the source side, we have a PDF string. Then we need a mechanic or logic to map it to glyph names. This is the core concept of every simple fonts, that you have a glyph name in between before you get to the target. The glyph name will then be mapped to something that is an actual glyph in the target font file format. And one thing I just want to mention this because I did it wrong when I first started with PDF. The PDF string here is you should only use the raw bytes. You have some places within PDF where it is allowed that you have a PDF string with a Unicode BOM at the beginning to interpret it as UTF-16. It's not explicitly stated in the PDF spec that you should not interpret the UTF BOM, and I was pretty unsure. So here a little hint: only use the raw bytes, no additional interpretation. To give you an example of how that looks like, at least that example is not too ugly. You have on one side you have a hex string, and this is mapped to glyph names. The glyph names here are very obvious. It's THIS and space, and IS again, which will then be mapped to the visual representation that we've seen here. Now, how is the encoding defined? Normally, but it's not required, a font dictionary has a encoding entry. It can be either a simple name, which it is in this case, which is one of the predefined encodings. It is Fernandes, MacRoman, or MacExpert. These are defined within the spec, the PDF specification, and you can just copy out the target mappings to use it in your software. Now, if you want to get more flexibility, it is possible to tune the standard encodings. That means you can reference a Fernandes encoding, for example, like it is here in this case, and apply differences. That means the character 39, as in the first line, is regardless what it was before in Fernandes, now to be interpreted as called single. 96 as grave, and 128 is a diaresis, 129 a ring, and so on. It is possible to reference a predefined encoding, but you can leave it out. In this case, this is one of the only places you can use the standard encoding. It's an additional encoding that is specified beside the Fernandes, MacRoman, and MacExpert encodings. And this is mostly used to do some customization, especially if you have font subsetting. And or if you want to access glyphs that are normally out of range in one of the predefined encodings. And that flash shouldn't be pointing to this position, but okay. One note, because it is possible is not a good reason to make mappings complicated. I have a lot of documents where the differences contains the complete mapping of Fernandes. So there's a question.
The sure
So,
side.
I really sorry.
You have to be on the sure side.
Yeah, you never know if a specification will be changed regarding the embedded encodings. So I compared every single mapping with it the differences, and they used simply the existing predefined encoding and put it into the differences. Additionally, they did it wrong, at least on the source character side or on the code point side. So the result was awful. Okay, so keep it simple. If it's possible, keep it simple. There's no reason to do complex mappings in many cases. Good. With that knowledge in mind, how does the process really work if you want to map one character code to some glyph name, if it is possible? We have three possible situations as a starting point. We have no encoding specified. That means the encoding entry in the font is empty. We have a predefined encoding. It's a very simple situation. Or we have an encoding with differences. Now let's have a look at the encoding with differences. You first check the differences. That's important. The differences override the standard encoding. And map, if you found something within the differences, and map that to the target glyph name. If not, you have to use a base encoding. If no base encoding is available, or the base encoding didn't have any kind of match, you're a bit lost. You have to ask the built-in encoding. It is simpler for predefined. Then you check out simply the table and go on. If you have a mapping, if not, you have to use the built-in. There's a little exception, especially for true type. And that is defined in a special subclause for true type. If you didn't find a mapping using the differences and the base encoding, you check additionally the standard encoding if you find additional or have an additional matching mapping. Another thing is for type 3, because it doesn't have any kind of embedded encoding or built-in encoding, it's simply not allowed to have to leave the encoding entry out. And if you're not finding a glyph name with the possibility I told you before, it's simply not possible to look up the appropriate glyph. Excellent. So once we have a glyph name, how do we find that the appropriate glyph within the target font? If we have to, in case of type 1, if we have to use the built-in encoding, we use the encoding entry that is inside the font. That is often a problem because it is exactly the same name and same name object within a true type, a type 1 font and a PDF in the set of PDF specification. So what I mean here with encoding is what stands inside a type 1 font. And if you have a mapping, be happy, load the glyph. If you have a glyph name directly from the previous mappings, everything is fine. Go ahead, load the glyph. It's getting a bit more complex, but not too complex. If you have CFF, you have to use the CFF encoding table, or it's called index in the CFF jargon. And with this, you get a glyph name, and with a glyph name, you can map to the glyph index within the CFF font itself. If you have a glyph name from a mapping up front, you're happy, you can go directly and collect the glyph. Good. If we look at other types of formats, for example, here, true type, special case, symbolic. It gets a little bit more complex. First of all, we have the character codes. This is one thing that I have to mention again. Symbolic fonts, symbolic true type fonts, ignore any encoding entry inside the font dictionary. Even if it is there, it will be ignored. And even Adobe Reader does it, I guess. It will be completely ignored. Instead, you go directly onto the CMAP tables within that font. The process is as follows. We check if we have a 3.0 CMAP, that is the Microsoft symbolic. If it is available, and this is something that is defined inside the spec, but something that I didn't believe, you use the character code that you have and prefix it with 0, F0, F1, and F2 in sequence, and try in each range to find a mapping. This is really iterating over the table. If you have found a mapping, it's great. If not, we'll see something later on. If a font has a 1.0 CMAP table and no 3.1, we have to use the 1.0, this is the Mac Roman CMAP table, and check directly for the glyph. Now, if we have no match with this situation, I have a place here. It looks better in the PDF. But it's a little excerpt from the PDF specification that made me personally cry like a baby. If a character cannot be mapped in any of the ways described previously, a conforming reader may supply a mapping of its choosing. In other words, if you're fucked up in that situation, the only chance is to ask Adobe what they did in that situation. Because we, as we are your developer, we have to match the results that Adobe has. So we are a little bit lost in this situation.
Well, if you get in that situation, the font is so screwed up anyway that
You're right.
yes,
You're right.
then all bets are off. So I mean,
Yeah, but the problem is explain it to our customers.
I'm,
Let the customer pick.
customer pick a new font. I think is what you have on that.
Yeah, this is a problem that we're facing on a regular basis. I have to say.
Are you really finding that many fonts
Yeah,
that are
that's-
falling into that category?
Yeah.
Really? I'm surprised.
It's always subtle little things, but we have situations where Adobe does, the reader does a little bit additional magic and finds the correct glyph. It's completely clear that the document is broken. It's crap. It should be tossed away. But normally we have documents that are within an archive, so tossing it away is not always a good idea. And reader does a little additional mapping. That little example made me personally cry. Now, what happens if you have a true type font that is non-symbolic? In this case, again, you check two types of tables. You have the free one. This is a Microsoft Unicode table. And in this case, you use the glyph name that you have matched before and map it to a Unicode value back. Happily, there is a very useful little list. No, little is wrong. It's a quite long list from Adobe that maps the glyph names back to Unicode characters. And then you map the Unicode values using the 3.1 CMAP table, subtable, I have to say. If you have no 3.1, it's the same process with 1.0. The problem here is, and this is also an excerpt from the PDF standard, the standard Roman encoding used on macOS. I'm a Windows user, I'm honest. I have I had no idea what is the standard Roman encoding in macOS. It's basically, I found all
It's
data.
Mac Roman encoding.
It's Mac Roman encoding, exactly. It's exactly the same mapping as Mac Roman encoding, the predefined encoding has. But you have to know that because it doesn't stand in wording in the
We should fix that in part 2. That really
I give
should
you
say.
a
You make a note to me. Okay, good.
Okay.
Project leader's here. He'll take a note.
Why don't you take a note for me?
Yeah. Okay.
Okay. If all that fails, there's one last fallback to try to find a glyph. The TrueTypes fonts can have a so-called post table, the postscript table, which is simply a postscript compatible naming table. You can give the font postscript names, and you can give any glyph postscript glyph names. So if you can't check then the post table, do I have any working mapping for this glyph name, and use the glyph that is described with this name. And if you have, if even that fails, outcome is not specified. Let's go back to the note I have been showing before. This counts for the other mapping too. Okay. Good. Any questions so far? Well, everyone is waiting, so we want to go home. And I think okay. We already talked very quickly and briefly about the composite fonts. The concept is relatively identical to what we had with the simple fonts, but with some differences. You have on the one side a PDF string, as before, but instead of mapping to names, we're mapping to CIDs, character identifiers. And the important thing is, the concept of this mapping is completely different. We're using CMAPs. Now we have a problem because CMAP is also a term that is used within TrueType files. I don't mean the TrueType CMAPs, I mean the Adobe CMAPs. I call it Adobe CMAPs, which is a PostScript based dialect to define mappings from input bytes to something else. It can be almost everything. And the key point is that you are able to define a CMAP that uses multiple bytes as input. And due to this, you can generate mappings that are able to access a lot more glyphs than 256. And from the CIDs, and that depends on the font format and on how it is done in detail, you get back to the glyphs. Again, even there I was a little bit stuck. We use only the raw bytes. When I understood that for simple fonts I had to use the raw bytes, I've seen that the CID fonts or the type 0 fonts use multiple bytes. I thought, okay, that's great. Now I have to do the decoding using a UTF-8. It's wrong. Use the raw bytes. It's up to the CMAP to do the interpretation and consume the amount of bytes required to extract a CID. To give you a simple example, it is made up, but to have an example, instead of getting any kind of glyph name, we're faced to a list of numbers, and the result is in this example the same. So, how do composite fonts look like? Basically, it is an identical font dictionary to a simple font, with the exception that it has a type 0 subtype, and it has descendant fonts. Again, this is one place where I have been lost when I implemented it first, because of the term descendant fonts. I thought, okay, now we are lost because we have multiple fonts we have to support at one time. It's not. It is only a single font allowed as a descendant. even if there is declared an array. If an array has more than one element, it's a bug of the document, of course. And
It's because, just FYI, it's because PostScript actually allows multiple descendants, but when doing PDF, we realized that was a complexity that wasn't necessary.
yes, it's for sure a historical reason.
Yeah.
But the moment when I've seen the spec, I saw descended fonts and ran away in panic. We have within those composite fonts two very important definitions. First, the type null font itself has an encoding entry, and as you can see, it doesn't seem to look like one of the predefined encodings with ANSI, with Mac Roman or Max Expert. It's another set of pre-existing encoding. Thus, the table, I think, is about 2 pages long, which CMAPs, standard CMAPs, have to be supported by reader applications. And if you're not happy with the predefined CMAPs, and there's a lot of them, you can even write your own and embed it inside the document. So that means instead of a name, you will find here a reference to a stream object containing the stream, the CMAP table, the Adobe CMAP. I wanted to use that term. Additionally, we have the CID system info, because if you have a CID that is basically just a number, the number itself is completely meaningless. To have to get some meaning inside these or for these CIDs, you need the so-called character collection, and the CID system info defines which character collection shall be used. In our case, it's Adobe Japan 1, and there's a lot of publications from Adobe especially, which show which CID is meant with character or which glyph. So there's an explicit mapping. And we will have to use the CID system info later on. Okay. Now, the basic concept, if you have a CFF descendant, is to use the character codes, map the character codes to CIDs, and there can be input of multiple bytes, and the CMAP decides which bytes will be used. And then, if you have CID operators, that are 2 or 3 operators in a specific dictionary of a CFF font, you use the CID to map directly to glyphs. If not, you must be the other way on. If it has a CID operators, you have to use a CFF cowset. If not, you have you use directly the CID as the glyph index. The much nicer way, because no additional weight in between. Now, how does it work for TrueType? TrueType has no notion of something like a CID. So what you do here is something in basic, very simple. You use a encoding CMAP to map it to somewhere, and additionally there is the possibility to specify a CID to GID map within the TrueType font, in the TrueType font dictionary, so to say, which is simple, a big mapping table. So for this CID, please use the following glyph ID and use for the target glyph. It looks again not very nice. I have been using a font that looks much better than this one. I have another excerpt that made me cry again. It's this one. Oh my goodness. It's about what happens if the font is not embedded inside the document you have defined to be a TrueType descendant. When the translation about the from CIDs to anything in the target font, and the important thing is the last sentence. The means by which this is accomplished are implementation dependent. Again, are dependent on how Adobe does the mapping. So I want to provide you at least with one solution. What we did load the appropriate UCS2 CMap. This is something that we will see in the part of text extraction of how to get that. UCS2 is almost identical to UTF-16. We map all CIDs into UCS2 and map UCS2 values to Glyph values using the 3.1 CMap of a TrueType font as long as it is available, or the 0.1, which is Unicode 2.0, to get the target Glyph. At least one solution I hope could help someone here. Good. Last part, extracting text. First of all, I fear that it won't be working as I expected it. Glyph selection is identical to text extraction. Is simply wrong. It is not identical. There are subtle differences that you should care about when working with the text extraction. So, to see how the whole stuff works, simple is very easy because you use the base encoding to map the character codes into glyph names. And from there on, you'll use the Adobe Glyph list to map the glyph names back to Unicode values and you're done. Hopefully. On the other side, if you have a composite font, you use a mapping table to map the character codes to CIDs and then back the CIDs to Unicode. And the process of that I will be explaining it on the next slide. Both of these concepts can be overridden, and if you have a possibility, you should do it in most situations. If you're using the simple font with an embedded encoding, you can leave it out. Use it to Unicode CMap. The to Unicode CMap is a CMap that explicitly states that this character code on the source side maps to the following Unicode character on the output side. So, this can be done for the simple fonts and for the CID fonts. For the CIDs, you have a kind of embedded or predefined CMap to map CIDs to Unicode. And accessing
Before you get to that,
yeah.
So just one thing. So if there's a to Unicode if there's a to Unicode table, always use it. It always takes it always takes precedence. Which, and I'll point this out to everyone. It actually there are sometimes, even that's the way it should be done. It's actually interesting. We ran into an interesting situation within the last couple of weeks where it may or may not be a good thing. So but it is the way it's done. So the interesting situation was, in the text, visually, the glyph was an FI ligature. Okay? So the question is, what do you extract? Do you extract FI as two separate items, or do you extract the Unicode value for the FI glyph? Well, the answer is that it's whatever's in the to Unicode table. I mean, by the time you go through all of this, it's whatever in the to Unicode table, which means, as you pointed out, it's up to the author. So you can actually have two different files, or actually the same file, two fonts in the same file, that extract out the FI differently. And that's perfectly reasonable and valid. Because one of the things that you can do with the to Unicode table, as we were saying, is it's not a one-to-one mapping, it's a one-to-many mapping. So you can actually get out F and I as the single result for what was one code in the file. But that's part of the reason is the to Unicode map gives the author or the producer control over exactly what's getting extracted.
I have one other note. You can't always trust the two Unicode tables. There
It's
are tools
exactly-
out there that generate
exactly.
bad ones.
This is perfectly correct. I've been
One of
facing
my
such a
favorite pieces
problem
of code.
last week. We have a document which is a form, and we were completely frustrated because we were unable to extract the text. We didn't try what Reader does in this case, and I think about 3 hours of trying, we tossed the document inside Reader and had a look what Reader does, and it's simply we broke into Unicode table which had precedence for us and precedence in Reader simply led to garbage, completely garbage. And you're lost in such a situation because if you have it to Unicode table, you cannot trust the normal encodings because they are messed up in almost every case. So this is one reason why any PDF reader is often not able to extract any kind of text, or indexing goes completely wrong.
Right. But that's the rule. Obviously, if you want to go above and beyond in the case where it's crap, then go ahead. But at least as far as the right, throw it away and build from scratch. Or yes, that's
okay. So the last thing I wanted to explain is how to find the CID to Unicode mapping table. This is something I didn't find directly in the PDF specification. It took me quite a while. It's not because it was at the wrong position. It was because I was searching at the wrong place. But anyway, here it is very important that you use and have the CID system info available. If not, you're lost. Eventually, it is defined within the CMAP that is defined inside encoding. You use the character collection to generate a CMAP name. And this name is normally part of the standard CMAPs distributed by Adobe for use in all reading applications. And that's important. All those CMAPs exist and may be used. For example, for Adobe Japan 1, there is one CMAP table available that maps to UCS2. And UCS2, as I said before, it has a 96% match to UTF-16. So using this way, you're getting the CIDs into Unicode values. But there's also a predefined CMAP called identity. If you're facing such this CMAP within a font and you try to find an appropriate target for exactly that CMAP, you're lost because identity has no Unicode expression or equivalent. Exactly. Okay, so I'm a bit ahead of time, 10 minutes. I thank you for your attention, and I'm here to ask your questions if you have any. Yes?
How does work right to left text direction extraction?
Good question. There's no native notion inside PDF. You have to lay out explicitly.
Text direction, isn't it?
in tagging.
Yeah.
In tagging. So
Excuse me.
yeah. So in tag PDF, you can stipulate a direction, in which case you know.
Tag
The-
your file.
To tag your file. The alternative is that if you have the Unicode values, you can you can map the Unicode values into known sections and say, oh, okay, this is in an RTL, and do it intelligently. But that's actually not expected because unless, especially in the case of an untagged file, the glyphs are going to be laid out. They'll be laid out in the right order, so you're not going to reverse them accordingly. So things will just come back out. You'll get them in the content order, in the visual order. You have to, and then what you do is you would if you want, be smart about intelligently putting in the Unicode direction flags, but it's a little extra bit. There's nothing that's all external. It's not handled. Unless you deal with tags.
Unless you get tagged.
Unless you get tags.
Isn't there an additional tag inside a dictionary called reading direction? Or is it part of a tagging tree? I'm pretty unsure.
Reading direction is tagging tree. But there
Tagging tree?
is, however, another thing which you didn't talk about in terms of text extraction, though, which is you didn't talk about alternate text.
Okay, yeah, that's
Actual text.
Actual text, that's what I meant.
Actual
Thank you,
text,
actual
yeah.
text. I always get that backwards. All actual text. Yes.
To be honest, I concentrated very much on the low level details. To be completely honest, yes, it is possible to have an alternative representation on alternative text, actual text better.
He's right.
As a replacement of what would be extracted otherwise if you select as a text passage. That is especially useful in situations where you have line endings or line wrappings. That's one of the most used as I know.
That's one. Sometimes for abbreviations like doctor to DR. Sometimes. And actually, we've seen it probably the most is in certain foreign languages. Arabic tends to be one that throws out a bunch of interesting times for actual text in order to get because you'll see one and you'll see one rendition, but you really want to put in a different thing in the actual text to be extracted. There's differences between Arabic and Farsi and Persian and the variants, and so that gets a little funny. It's one place we've also seen it as well.
Is this always present?
No, it's almost never. It's an unusual thing. It doesn't get written. Most, I would say, the only producers I've ever seen do it are Adobe producers. I've never seen a non-Adobe producer generate actual text, but that doesn't mean it isn't there.
But if I use regular Type 1 fonts or open type fonts in
it has nothing to do with the font format or anything else.
So it's always there if I do an export out of InDesign.
No, it's only there if you can't explicitly control it. It's something that we do behind the scenes for those cases that are special cases. I'm not aware of any way you can. There's no way to say it in InDesign. We even generate it out of Word, like PDF Maker out of Word. Under certain circumstances, will generate these things. But there's no human control for it that I'm aware of.
There's also the concept of reverse characters, right? Reverse characters.
If you are using a transformation matrix, yes,
No,
but not really.
there's a container type. Like it's something in the specification / reverse cars.
Oh, you're talking about in tagging?
Yes.
Yes, in tagging, yes.
Yeah.
Right.
But in the page layout itself, it doesn't exist. You're painting every glyph directly on the page, depending on whether on your current graphic state. So flipping a glyph or doing things like that is done by using the transformation matrix, either the text transformation matrix or the general.
Do you know a way to bring a open type font into a PDF as an open type font?
Depending on the outlines or the type of open type font. In most cases it is no problem. If you only have bitmap glyphs, it is not possible or not allowed. You must have either true type outlines or CFF outlines, if I'm not completely wrong.
Well, in 1.6 we added native open type, so you can actually just take the entire open type and throw it in. But in that case, it's a full embed. You'd never see a subset version of that. Yeah. And this goes to you're trying to generate it for the thing. Yeah, the only two ways I'm aware of are Acrobat will do it for forms, which is why it was originally invented, and Distiller will do it if you set the flag in Distiller.
But both only for PostScript type open type.
Yes, not for true type, because again we put it in for a very specific need, which was form filling in foreign languages.
I was hoping that
I don't know.
Another trick.
I don't know if PDF. Oh, I was going to say I don't see Sebastian. I was going to say I wonder if PDF Lib has that as an option.
Well, he's away.
Yeah, he's here somewhere.
And then only one other comment I have on extraction, because I've seen this with especially international characters. If you're using a proper layout engine, the fonts have hints based on whether glyphs should actually be reversed when printing, based on what letter comes before or after them. And once they end up in the PDF, you will extract those incorrectly from what they were originally put in. They will be typed one way, they really want them flipped, but there are hints within the PDF engine or within the fonts. So you generally, to lay them out, have to use a layout engine.
Well, that's where things like what I was talking about for actual text. That's one of the good cases where actual text is very useful.
You can generate those through like that engines like IBM's ICU. They have a really good layout engine that will detect those and fix them for you.
Okay.
One more question, and maybe naive, but how did these incomplete font encodings come about in the first place? Was it just people cutting corners, taking shortcuts, like, well, Adobe Reader's gonna know what I want to put here as a character, or was there a real reason behind it?
I started at the beginning. The reason why I started at the beginning with a presentation to see what is everything involved in the process of finding the glyphs is because of exactly that problem. In most cases, people and generators, or people writing the generators, do not completely understand the process of how the glyph lookup works. So they simply do something, test it one time with Reader, and after that they're happy. They're not asking any questions. And this is one problem that we are facing, and also caused a little bit by the excerpts that I have put inside the presentation, because in most cases it's up to us of what we're doing, and it's guesswork. And we are doing different guesswork than Adobe does. Simply, it's normal.
If you mean, are you asking like why can you even have a difference in coding, as opposed to why is everything not just WinANSI or Unicode or something like that, or?
No, it was rather like, why can you fall back so far as to where it's basically an implementer's decision what glyph to put
Because
there,
somebody
right?
did a crappy job.
Yeah, completely.
Yeah.
Exactly.
Can I touch two things? One, maybe they are not relevant into a PDF-A world, but what if the font isn't embedded? You have to render something, and there is no clear substitution algorithm. So everyone does what actually he thinks is the best, and that's why we do have different results. That's for one thing. I'm not sure if there are directions or not in this.
No,
So
font substitution is totally on your own,
Exactly.
as it should be.
Another thing, there's still a lot of PDFs out there with the old base 14 fonts as well. It's not valid since, I don't know, help me.
Well, actually, you can still, base 14 are still present in 32,000. It's just that Adobe nobody carries the base 14 anymore. They're just not special cased. But the names are still present. The spec still talks about them, but processors process them no differently.
So you don't, the spec doesn't actually specify what the base 14 font should look like.
Correct.
It's up to you, how do you implement them?
That's correct.
Okay.
Yeah.
The target names are specified within the spec.
Yeah, the
Yeah,
names,
so
but
the name, yeah.
matrices
The
and
the
things,
right, the
I know.
glyphs, the metrics, all that stuff is not spec.
You can buy them from URV
Yes, I know.
plus. We didn't ask the question how much they will cost, because we already knew from others that we have to spend all the money that our company has to embed in our product. Yes, you have to find
It
us.
clearly says in the spec that the viewer does have to have them.
It used to. I think we're pretty sure we got rid of that, and because
the
we don't. I
sentence.
mean, Adobe Reader has not carried the base 14 since 5.
So what do you render? You
We
substituting?
we use OS fonts.
Oh yeah, yeah.
Yeah, we do not carry. I mean, we carry the smallest complement, which is we carry Courier, which is the last resort font. We're you have no other alternative, and we carry our own custom symbol font because symbol is one of those ones that doesn't substitute well. And then we also carry some foreign language ones, but Times, Helvetica, the Times and Helvetica families are all loaded out of the OS because they're there. We have no problem. There's no reason not to.
And unfortunately, they're not there. This Arial is there.
Yes, but as far as the average user can't tell the difference.
Yeah, we're doing basically the same thing. We have some static mappings for different OSs and try to map them first. If that fails, we have some fallback to try to find something useful.
Which is what you have to do for any non-embedded font. I mean, that
Exactly, yeah.
was sort of our
Exactly.
rationale, which is why treat them any differently than we treat any other non-embedded font.
It's not
Oh,
allowed in
what time
any
is it?
standard.
Oh, then we got to go.
Okay, thank you very much.
Thank you. Thank you, Doc.